Greetings from Ravichandran. Welcome to the Mountain Path, the world of finance. So, this session we will discuss how to optimize a portfolio of 5 stocks using Solver, using real time stock prices, and how to construct an efficient frontier in Excel. So, what are the pre-requirements? Some understanding of basics of risk and returns, basics of modern portfolio theory, Markovich portfolio theory, and efficient frontier, and how to download stock prices using stock history function Excel, basics of solver and simulation of using what if analysis and data table. So we'll go through the following steps in this session. Download the daily stock prices of a chosen stock for a chosen period using stock history function Excel. Calculate daily log normal returns. Calculate discrete daily returns of each stocks from the log returns, and we also calculate sample variance of each stock. And we'll assume initially equally weighted portfolio. Using data analysis and regression, construct a covariance variance matrix. That will be a population covariance variance matrix. So how to convert the covariance variance matrix into a sample by multiplying by n divided by n minus 1, where n is the count of the number of returns. Using the assumed weight, calculate the daily portfolio returns. Using matrix multiplication formula, calculate the portfolio variance, portfolio standard deviation, and annual portfolio standard deviation. So before running the solver, we will also keep a copy of the data. Then we use solver to minimize the portfolio to get the revised and returns with the revised and weights of the stocks. For getting the efficient frontier, we will try to use a rand array function in Excel, and thereby we'll simulate weight for the each stocks. So for rand array, we'll choose since you have chosen 5 stocks, we'll choose rand array 5 row, 1 column, and we'll use a data table to simulate 10,000 times to get risk return combinations, and you use a scatter plot to show the efficient frontier. And every time we press F9, we'll show different simulated efficient frontier. So let's quickly go into how do you. So in Excel, and we have what is called, we go into the data. So we have what is underneath the stocks. So we can type any stocks, and we'll get the properties. But you can straight away use what is called data stock history function Excel. Stock history, the first input is and XNSC colon the name of the stock, that is script SBIN here. So if you use this new function that is in Excel, for example, if you type ITC in any cell or name of the stock like SBIN, you go here into the data, you just click stocks here, and it will come. So you have to select the National Stock Exchange or a Bombay Stake. So you just select it. So you'll also get an added feature. There is a small triangle on top. So you'll choose whatever data. Let's say you want to choose a beta of the stocks. So you'll get a beta of State Bank of India. So this new feature is incorporated in Excel, and so that we need to utilize. So I've selected for today's exercise 5 stocks from NSE, National Stock Exchange of India, State Bank of India, ITZ, Infosys, Adani Enterprises, and then Larsen & Toubro. I've taken the starting date as 24th May 2019, end date as 24th and May 2024. So 5 year of daily stock for closing price of these 5 stocks. I've downloaded the data. Now the next sheet actually, and I'm going to use is the download the stock price, and to calculate the log returns. So the log returns, the formula is the log of today's price divided by yesterday's price. So I got the log returns of these 5 stocks. Now, so then we will assume initially an equally weighted portfolio. In this situation, since we have got 5 stocks, 1 by 5, so 20% each. We'll also calculate. So the return that we calculate, if we calculate the return average, that will be a continuous compounding return. So what we will do is we will convert the continuous log return into a discrete return by taking the exponential. So exponential of average of the returns close bracket minus 1. So exponential r minus 1. So we lose it, and so this is the discrete returns of each stock for the period that you have downloaded. Then you'll calculate the daily variance, sample variance. This is just to verify our covariance variance matrix calculations. So we'll use the data analysis tool pack, and we'll use the data analysis. We'll use so let's go into the data. So we go into the data analysis. We'll use what is called so the covariance, and if you use a covariance, and it will ask for and the stock, we'll choose the entire return. So that means so let me just show to you. Let me just delete this data. So just delete the data now. And so we want to take a covariance variance matrix for population. So go into the data and go into the data analysis to the covariance. So initially it asks for the input range. The input range is the array of the log returns. Then click the label. We are choosing the label also where we want to have the output. So we are already chosen a specific place where you need to display. We'll choose this place. So click OK, and so when you click OK, then what happened is you have some of the cells are filled up, some of the cells are not filled up by default. So these cells needs to be filled up. You just copy this one, Control C, then paste transpose here, and so you have filled up this. For the next 3 columns, again take this data, Control C, and paste transpose here, and then these 2 data, so we can Control C, again paste transpose. So we got the filled up. The last one we can manually fill up, okay, and there is nothing but so we'll just take this data, okay, and this one. So now, so convert this as a percentage to make it look better, and so we got the covariance. So what you got is the population covariance and population covariance matrix. So we need to convert it into a sample one. So how do you do so? First you calculate what is called the count of the number of rows, as keep it as n minus 1. So divide n divided by n minus 1. We'll multiply this and n divided by n minus 1 into the population covariance matrix. And so how do you do so? So we just is equal to, we'll keep it in the cursor and highlight this one. Then multiply this population covariance matrix and into the n divided by n minus 1. And now, so we got the data here, and so you can check whether the data, the covariance is correct or not. So this will tally the cross diagonal, and I think this will tally with the sample variance that you have already calculated. So you can check it, and 0.46, and you got the correct 0.27, and you have 0.336, and so you got everything, whatever you calculated, it is correct. So our calculation now, initially we assume the weight, and so we can copy the weight and the return here. So we can put transpose bracket, and first we'll copy the entire thing, and then is equal to, and transpose open bracket. So we'll use the assumed weight here, this weight, close bracket, and since it's an array function, we'll put Control Shift Enter. So the weight is automatically copied that. If you do it correctly, let me do it again. So we'll copy the entire thing, then is equal to, or we can manually link it also. Better to do like this, transpose, okay, and so this horizontal weight which you have assumed, then Control Shift Enter. Now we got the weight here. Now we need, similarly we copy the whole thing for our return calculations, and so is equal to, and transpose, and so you'll take the discrete return, horizontal discrete return, and Control Shift Enter. Now we got the horizontal return. Now the sum of the weight is 100% or 1. Now we have take the sum product, and to calculate what is called the weighted return on the assumed the weighted portfolio. So now, so this is your and so sum product of the weight array and comma the return array. So, you have done it wrong. Sum product, this weight array comma return array, close bracket. We got the return. Now we will calculate. The next final step is to calculate using the covariance variance sample. The calculation is a sample here, covariance. Now we use the matrix multiplication, and so first we will take m mult matrix multiplication. Again we will take the m mult and close bracket and open bracket. Transpose here and the vertical weight array and close again. Now take the covariance variance matrix, close bracket, comma, again take the weight array. Now Control Shift Enter. So whatever you get is actually the portfolio variance. Now if you take the square root here, if you take the square root, okay, and you'll get the what is called and the portfolio standard deviation. This is the daily standard deviation. Again multiply this by square root of 252, assuming 252 trading days, and now you got what is called your annual portfolio annual standard deviation. And similarly, you want to multiply the daily returns by 252, you get annual returns. So this is now what you need to do is, first step we need to have what is called how to calculate and the minimal risk minimum variance. So how do you calculate? So how do you, and so what is our main objective today? The main objective is to calculate, optimize the portfolio. So first optimize the portfolio by running the solver. So highlight the annual standard deviation here, the annual standard deviation, go to the data and go into and solver here, and we'll actually minimize, and by minimizing this particular cell and by altering the weight, this is the 5 stocks weights, we alter that. Then by putting only one condition, and so we'll add the one condition, that means that we'll add, and so this cell and and will be equal to and 1. So will be equal to 1. You click OK here. Now solve it. So now you run the solver. It will take a couple of seconds, since the Excel sheet is linked with the live data. It takes a little more time. So you got a solver has found a solution. You click OK. Now what you got is actually and different weights, and this is the so this is the efficient and optimal weights to minimize the risk. So we got there, and so this is the very important. The first step, we use a solver to optimize the portfolio by minimizing the risk. So if you can see that the previous risk, and so if you really calculate, let's say that the previous risk, and let's put the weight here. So if you really calculate, so the previous risk was 23.29. Now the risk is reduced from 23 to 20%. The risk is also slightly reduced because we have minimized the risk. The second important step is to construct an efficient frontier in Excel. So what I do is I have copied the covariance variance matrix here, and then I'm using a rand array function. So how do you calculate? So rand array is a rand array. So since we have 5 stocks, we'll take the 5 rows, comma 1, and so we just enter. So you will have a different weights and take the total here. Now when it comes to your stock, what you'll do is you'll calculate, you'll take the weight of the first one divided by the total weight, or then you just fix the denominator, and then copy that. The total will become, obviously it will become 1. So every time you press F9 here, the random array generates different weights which are mapped to the actual weight. Now similarly, you want to calculate and the return sum product of the simulated weight and comma the return. Okay, comma the return. And now, so this is the return. So you just look into that, and so so the so this is the thing. Now what you need to do is, again automatically, and every time you press F9, so the portfolio standard deviation portfolio return keeps on changing. Now what you need to do to create an efficient frontier in Excel, and so you have to use first these two cells has to be linked here. So the simulated one iteration you've done, this is the risk, and the second is we'll also map the returns here, and we'll also map the return. So we got one risk and return map now. So what you can do is we have to create 10,000 and trials. So in Excel we don't need to read, so just put one here and go into what is called, and go into the fill, use the fill series, and you put columns here, choose a linear, and the value, step value is 1, and you calculate 10,000 you put now. So you'll get so you can fill up the serial number with the 10,000. Now let's highlight, so this simulated risk and return, highlight the entire, copy this one, go to the data, what if analysis using data table, and so what you can do is under row input don't input anything, column input also don't input, just click anywhere outside, and this one just click OK. Now so you got what is called, and the simulated risk and return, and so now so you get this. Okay, you get every time, and let's see that. Let's see. So somewhere down the line I made a small mistake. So this has to be mapped, and with this one, not that one, the simulated risk. Similarly, this has to be mapped with that return. Now we got the various risk combinations and of return. So every time you keep pressing F9, the different risk and return combination changes. Now you can simply map it in there, and so how do you do so? So we can create an efficient frontier by actually copying this risk return, insert, and we'll use a scatter plot. So you'll get a nice graph, and so this is an efficient frontier, and in Excel. Now we can, let me cut it and paste it on top, and so you get a wonderful efficient frontier, and you can even format the whole area to make it look better. But the idea is we have created, we can use 7 stocks, 10 stocks in Excel. But if you do Python, so you'll get you can use and 50 stocks or 100 stocks. You can do simulation, not 10,000. You can do simulation of what is called 5 lakh times, 10 lakh times, and 500,000, 10,000. So it will become much better. So each dot in this efficient frontier is combinations of different weights of the stocks that you have chosen. So thank you for watching. Hope you and enjoyed it. Thank you.